Hello students, I Sujata Pownikar from Department of Electrical Engineering, AISSMS IOIT. Welcome you all for today's session on Introduction to Electrical Active Reactive Apparent Power. Contents of the session are power triangle, concept of active power, concept of reactive power, concept of apparent power. First we will see electrical power. So energy, we know that it is power over the time or work done over a time. So we can see that energy is equal to power into time. But what is electrical power? Electrical power is nothing but the product of voltage and current. Therefore, electric power is related to energy and the unit given for electrical energy is watt second or joules. Electrical power can also be defined as the rate by which energy is transferred. In electrical power, it is again divided into three types of power, that is apparent power, true or active power, and reactive power. Here we can see triangle which is known as electrical power triangle. In electrical power triangle, x-axis component or base is denoted for active power or true power and the unit of active power is watts. Vertical component or y-axis component is shown for the reactive power and symbol is Q, and unit for reactive power is VAR, that is volt ampere reactive, and diagonal or hypotenuse of this power triangle is called as apparent power and it is measured in volt ampere, that is VA. On the right hand side we can see two power triangle. One is showing positive x-axis component, that is lagging power factor, it needs reactive power, and the right hand side diagram shows reactive power which is downward on the y-axis, so that is called as leading reactive power. So this leading power factor correction is used in the inductive load. Trigonometric relation between three power, that is true power or active power, reactive power and apparent power. So these three types of power are trigonometrically related to each other. In right angle triangle, P, that is horizontal component, is the adjacent length and this is nothing but the active or true power. Active power is the true output of the device or net output of the device is called as true power or active power. Q is the opposite length of the angle. So this vertical component is called as Q and it is denoted for the reactive power. And the hypotenuse or diagonal is shown for the apparent power, that is the square of true power and reactive power. So P square plus Q square will give you apparent power square. Phi is the impedance phase angle or power factor angle. So this angle made by the hypotenuse with the adjacent side, that is called as phi, and that is nothing but the power factor angle or impedance angle, and it is also called as ratio of true power to the apparent power. This power factor in a layman term, it is also called as how efficiently input power is transferred to the output or as a output power. That factor is nothing but the power factor. The opposite angle is equal to the circuit impedance phase angle. Here we will see one by one. First you can see this blue color triangle as we discussed before. So this P is nothing but the active power. It is also called as real power. It is also called as true power. It is always measured in watts or kilowatts. And formula for the active power is P is equal to V I cos phi. Now vertical component is nothing but the Q. That Q means reactive power and formula is VI sin phi and unit is VAR, that is volt ampere reactive. P square plus Q square root, you will get apparent power, which is denoted by S, and the formula is simple, voltage into current. So S is equal to VI. So this is power triangle. Now we'll see one by one. The active power is the real power consumed by the load. It is also called as true power. See, there are different names. Active power is the actual output of that load or device. This is also called as real power. It is also called as true power. Whenever we are saying this is 40 watt, 60 watt or 2 HP, 5 HP, that we are always dealing with the active power. Second, reactive power. It is a Q component, vertical component. So the reactive power is the product of voltage and current and the sine of angle between them. As it is vertical component, it is a sine component. So Q, that is reactive power, is equal to VI sin phi. Unit is volt ampere reactive or kilovolt ampere reactive. It is shown over here. Fine. Now next one is apparent power. Apparent power is the combination of reactive power and true power. It is called as apparent power and it is the product of circuit voltage and current without reference to any phase angle. Now here we can see by the Pythagoras P square plus Q square is VI cos square phi plus VI sin square phi. Cos square phi plus sin square phi, you will get 1. So S will be only equal to V into I, that is shown in the formula. And if we want in another formula, we can write kVA is equal to square root kW square plus kVAR square. So that is a apparent power and unit is volt amps, that is VA. See, here there is no phi component. Now we will see one example. First diagram is showing fluorescent lamp as the load. This fluorescent lamp has capacitor for the power factor improvement. Second is incandescent lamp. That this is regular lamp at our home, that is yellow colored lamp, that is called as incandescent lamp and it is purely resistive. And the third one is induction motor. Induction motor is a motor which is having lagging power factor, that is it is having some reactive component, lagging reactive power. Now here you can see everywhere resistive component value is same, but the other component here capacitive component is there. This is resistive load and this is inductive load, that is why inductance is shown as 0.25 Henry. Now we will see one by one. For fluorescent lamp to deliver 60 watt as the active power or output. So this fluorescent lamp will convert electrical output or electrical input provided to it in the lumens or illumination function. So it will illuminate the area. So that is called as output of the lamp. So when 60 watt is the active power, then it is showing 0.74 leading power factor. So here capacitor is connected, that's why it is taking leading power factor. It means it is having leading reactive power. And incandescent lamp, it is again 60 watt but reactive power is 0 because in resistive component there is no reactive component, only horizontal component is present and power factor is unity for the resistive load. And for induction motor it is inductive, that is lagging reactive power and it is taking 0.93 lagging power factor. This lagging power factor also denotes that to deliver the same output power it will take more current. As the current will be more, there will be more I square R losses, lesser the output, lesser the efficiency, right? So if current to produce same output is increasing, then efficiency will decrease. And as current will increase, you will need more conductor area, so cost is again increasing. So to deliver the same output, if you have power factor unity and power factor 0.93 lagging, then at the unity power factor current required is less, because formula P is equal to VI cos phi. So here cos phi is 1 and here cos phi is 0.93. So current requirement will be more if you will refer P is equal to VI cos phi. So this is how today we have seen all the three type of power, that is active power, reactive power and apparent power. Formulas for active power VI cos phi, reactive power VI sin phi and apparent power V into I. If the power factor is lagging, then to give the same output, current will require more and input power has to be increased. Thank you all.